Hello guys, today we will be discussing a very interesting video because many of the students, many of the people, they keep on wondering like why some hormones are measured in picogram per ml, why some hormones are measured in nanogram per ml, why are the SI units different. So that we will be discussing in this video. So for that, first we need to understand what is picogram, what is nanogram, how are they different. So basically the picogram is 1 nanogram is 1000 picograms. Means nanogram is a bigger thing and picogram is a smaller thing. Just for example, to make you understand, like it is 1000 ml is equal to 1 liter. The same way 1 nanogram is equal to 1000 picogram. So why is there the difference in this? That I will be explaining. So firstly, we will look how the hormone receptor complexes are formed. So this is the circulation and this H is the hormone, this is the cell, cytoplasm and nucleus. So as long as the hormone remains bound to the receptor, till only then it is useful, and it is the ability to further the protein production happens only as long as the hormone remains bound to the receptor. So biological activity is maintained only while the nucleoside is occupied with hormone receptor complex. Okay, so that biological activity to maintain is very important because that only will lead to the production of the proteins. Okay, so but why, the question is why estrogen and in picogram and why progesterone in this nanogram? Means why the smaller amount of estrogen is required and why the higher amount of progesterone is required for the hormones to function. So the reason is there is long half-life of estrogen hormone receptor complex, and for progesterone the hormone receptor complex has a shorter half-life. It means that estrogen remains bound to the hormone receptor complex for a longer time, and that's why even the smaller amount of estrogen is adequate to produce the desired effect. So that also is one of the major reasons in the potency differences between different types of estrogens. As we all know, there are different types of estrogen, E1, E2, E3. So out of E1, E2, E3, E2, that is estradiol, is the most potent estrogen, and it's the reason behind its potency is because of long half-life of estrogen hormone receptor complex. The hormone E2 remains bound to the receptor for a longer time. That's why the E2 is the most potent form of estrogen. Okay. Another thing is duration of exposure to a hormone is as important as dose. What is meant by this? Like for example, there is one example I'll quote is estriol in pregnancy. Like estriol is a very less potent hormone when compared to E2. So estriol is very less potent, but in pregnancy it becomes a very important hormone. How? Because in pregnancy, otherwise estriol has only 20 to 30% affinity for estrogen receptor compared with estradiol, that is E2. But because it is rapidly cleared from the cell. Why it is rapidly cleared? Because the hormone receptor complex is bound only for very less time, that is shorter half-life, just like progesterone. But if the effective concentration is kept equivalent to that of estradiol, it can produce a similar biological response. Means the dose is also important. So if we maintain that dose for longer time, the biological response is equivalent to that of estradiol. So both things are important, duration of exposure as well as dose. So that's why in pregnancy, where the concentration of estriol is very high, it can be an important hormone, just not a metabolite. Okay, so that's why now we have understood like duration of exposure to a hormone is also important as the dose of the hormone. So because in nutshell, because whenever any hormone binds to the receptor, whenever any hormone keeps bind to the receptor, if the half-life of this hormone receptor complex is more, we will be needing less amount of that hormone. So that's why the estrogen comes in picogram per ml, but progesterone, because this complex half-life is very short, that's why the hormones like progesterone, cortisol, because of shorter half-life of this hormone receptor complex, these progesterone and cortisol, these need to be present in higher concentration as compared to the other hormones like estrogen. So now you have understood, whenever you see any hormone which is in SI units which are in a higher SI unit, it means that hormone has a shorter hormone receptor complex half-life. If you see any hormone in which it is like in picogram or femtogram, all these things are there, means the smaller units are there, it means that hormone has a longer hormone receptor complex half-life. So this was a simple concept, just it was a basic thing which we would have now understood. So thank you so much.